Hey everyone, so today we're going to be looking at solving systems of equations by multiplication, but today we are going to have to be multiplying both equations instead of one equation by a number to create additive inverses, and we're going to see what that looks like. Okay, so solve the systems of equations by multiplying both equations. Solve the following systems of equations. So we have 4x minus 4y equals -8, and negative 3x plus 5y equals 0. So the first thing we notice is that we do not have additive inverses, we don't have identical terms, and we don't have an equation in the form of x equals or y equals. So we know that we're going to have to be multiplying by something to create additive inverses. So I'm going to start by identifying the LCM of the coefficients of x and then identifying the LCM of the coefficients of y. So let me just move this guy out of the way. So the LCM of x, so we have a 4 and a 3. Hopefully, mental math, we can see that the least common multiple of these two numbers is 12. You can list the multiples if you need to. I'm not going to do that in this video, though. And then I'm going to do the same thing, LCM of y. So we have a -4 and a 5. So our LCM of 4 and 5 is 20. So in the past, looking at our equations, usually one of the equations contained an LCM, so we only had to multiply one equation. But we can see that for x, neither of these are 12, and for y, neither of these are 20. So we're going to be multiplying both equations to create these additive inverses. So you can go with the x and try to focus on making both of these a 12 and then a -12. Or you can focus on the y, focus on making this a 20 and making this that a -20 and this a +20. I'm going to go with the first one, the LCM of 12. It's a smaller number. I like working with 12, I don't know, but it's really just a personal preference. You can go with the y's, totally up to you. It's going to give you the same answer as long as you do everything correctly. So I'm going to focus on making both of these coefficients for x. I want one to be a +12 and I want one to be a -12, because remember, they still have to be additive inverses, and when you add them, they need to cancel out. So one has to be positive, one has to be negative. So I ask myself the question, what do I have to multiply 4x by to make that a 12x? So what you really do in your head, the mental math, is 12 divided by 4. And that's going to give us 3. So I'm going to multiply this first equation by 3. So I'm going to do that real quick before I focus on the second one. So I'm multiplying everything in this first equation by 3. I'm going to get 12x minus 12y equals -24. Don't forget to multiply to whatever it's equal to also. That's a big mistake that students make, is they leave out over the equal sign, they leave this number out. So don't forget that. All right, and so now the next thing I'm going to do is focus on that second equation. I want to make this a -12. So good news is it's already negative, so I don't need to change the sign. I don't need to multiply by a different sign number. I'm going to keep it negative. So what number do I have to multiply by for this to become a -12? So I'm going to do that same process. I'm taking my LCM 12 and I'm dividing it by 3. And that gives me 4. So I know that I'm going to multiply this bottom equation by 4. So I'm going to multiply everything by 4. That gives me a -12x plus 20y equals 0. So just multiplied everything by 4. So now you can easily see we have a set of additive inverses here. So I'm going to add these equations together, and these, when I add them together, are going to cancel out. Now do the math in your head. If for some reason they don't cancel out, that means there's something that is wrong. The whole point of this is to create a set of additive inverses. And if you're not doing that, then you're not going to end up eliminating a variable, and it's just going to be a little bit more complicated. So make sure that you have a positive and a negative. They have to be the same number with the same variable. All right, I'm going to add everything else. -12 plus 20 gives me a +8. Y equals -24. solved for y, divide by 8 on both sides, and we get y equals -3. Okay, let's take that value and solve for x. I'm going to do that right over here. Now, when we're solving for x, make sure you choose one of the original equations that you did not change. So I'm going to choose this first equation, what's in this set of parentheses here. 4x minus 4y equals equals -8. And I'm going to rewrite everything, but except for y, I'm going to write -3 because that's what we just solved for. Make sure you're plugging in for the correct variable and solve from there. So multiply here, we get +12. I'm going to bring down that 4x equals -8. Next step, we're going to subtract 12 on both sides. That cancels. So we get 4x equals -20. And then that last step, divide by 4. And you get x equals -5. Remember to write your answer as a coordinate, as an ordered pair, x comma y. So our answer here is -5, -3. So just to summarize what we did, we noticed that we didn't have additive inverses and we didn't have a situation where we could use another method like substitution or subtraction with identical terms. So we had to create additive inverses, and in this case we had to multiply both equations to do that. Our LCM was not listed in either of these equations, so we knew that we had to change both of them to create that set. You could have focused on x, you could have focused on y. Either way, you have to have a pair of additive inverses. From there, once you figure that out, you should be smooth sailing. We know how to do this. We've done this a few times already, where you just solve for the first variable, and then you're going to plug that into one of the original equations to solve for the second.